Hello everyone, so today we're going to talk about ocean currents. So there are two types of ocean currents, two broad categories. We have surface currents and deep water currents. Whoops, where'd my screen go? All right, so when it comes to surface currents, also called surface circulation, as it sounds, like the name says, they're at the surface of the oceans. They make up the upper 400 meters of ocean and account for only about 10% of all of the ocean in the waters, because our oceans are incredibly deep. We tend to just think of them from their surface because that's what's visible to us, but quite deep. So only about 10% of the oceans are moving, of the ocean water is moving about through surface currents. The primary force, the driving force of our surface currents, is going to be the wind. Wind blows, pushes on the surface of the water. And our wind blows in patterns because of atmospheric currents, as well as the Coriolis effect or Coriolis force. So the way this works is the sun is going to warm the water. Warm water is less dense than cooler water, so that warm water is going to rise to the top. It's going to expand a little bit. And so our winds are going to be able to push that warm water. This effect is greatest at the equator. And looking at this map, we can see that most of the warm water currents are near the equator. So they get pushed around, and they get pushed in patterns due again to the winds and the Coriolis effect. So in the northern hemisphere, currents generally move in a clockwise pattern. In the southern hemisphere, they generally move in a counterclockwise pattern. And these create gyres, so these large circular currents. So we have a North Pacific gyre, a South Pacific gyre, North Atlantic, South Atlantic, and then an Indian gyre. And we'll talk about gyres again when we get to talking more about our currents and and how they move pollution around, and that'll be later in this unit. Our other type of currents, we have some deep water currents or the thermohaline circulation. These waters make up the other 90% of the ocean, so these are the deeper waters. These waters move around the ocean basins by density-driven forces and gravity. Density difference is a function of different temperatures and different salinities. So with temperature, warm water is less dense. Warm water will be at the top, and then cooler water towards the bottom. Cooler water is more dense. All those molecules have slowed down and are packed closer together. When it comes to salinity, less water that's less salty, fresh water is at the top, and the saltier water will be at the bottom. Linked here are some videos to watch of demonstrations of these phenomena. But when we look at our global thermohaline circulation, we get our cooler waters are formed near the poles. They sink, and the water then is warmed near the surface. Now this is a very slow moving circuit. It takes roughly 1,000 years for one piece of water to make its way all the way through our entire loop, compared to our surface currents, while still not fast, but those can be measured in minutes per hour and not years to go through an entire surface current. So you've got some videos to watch. There's also, I'm going to add it on here real quick. Copy. I've got a video on how ocean currents work, which again, I encourage you to go and watch that video now that you're done watching our notes. See you later.